And it's quite loud. I mean, I can use I can adjust the master volume on here, I guess. Or play. Yeah, I can adjust the master volume on the. Okay, yeah. I was trying to get Guardian to work on the Steam Deck, but it doesn't seem like it doesn't wants to do that either. Have you looked at the Amy? So I haven't looked at it recently. I had the feeling that I've seen a draft of the Amy because the Amy development cycle is like 2 years. So I want to say I looked at the draft of the Amy at some point, but it wasn't anytime recent, so I don't remember anything. Hi. All right. We're gonna use this one because I think this game works. The entire Amy. I don't know if I really want to do the whole Amy. Sorry. Also, that's 15 problems, not one. If there's anything particularly good at the Amy, I'm willing to look at it. But I don't think I'm doing the whole thing. Sorry. That's. Come on, come on. Please just load my Steam games. Oh my god. Alright, cool. Alright. Come on, get over here. Can I? Is there a button that lets me just grab 16 Zoombinis? Oh my god, there's a lot of Zoombinis here. Come on, friends. We're going on a trip. Actually, I think the volume on this is just real high. X in. Okay. That looks like a normal math problem. Okay, let's go.
There's no sense leaving it up to chance. Lure the fleas off the tree branch.
Amy P13. Okay. Anyone want to help me with it's there's a name for this problem, but I don't remember what it is. It's not graph isomorphism. I thought I had graph isomorphism in my head at first, but that's not what this is. It's I don't know. Okay, it's hypergraph isomorphism if you treat Zoombinis and fleens as hyper edges with 4 vertices, I guess. However, that seems really stupid, so I don't know why you would do that. Let's see, 4 4. Should be those guys. Blue, blue. Crap. Okay. Hi. Alright, so what was I trying to do? I forgot already. I thought. Oh, I messed up. Okay. Cars. Should be this one. Wait, what? No, 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 no. Was it the other one? It was the other one. Frick. Oh, this is too hard to do in my head. I'm sorry. Great. Okay, hat, green hat. Only one person has a green hat left. And then, okay. Red nose, sleepy eyes. Should be this one. No, don't lag out. Wait, did I lose one?
The intrepid band continues. Bravely onward.
Oh crap, I lost one. Rip me. I actually lost one. Very sad. Okay, wow. They only give you, oh, come on. Seriously? They only give you 2 errors? 1 error? Alright, line. I'll keep going. There's 15 at the...
Nice, Charlie. Very nice.
Okay, okay. Da-da-da. I'll just wait until one of them. Alright, so... Ah, crap. Wait, what? Wait, how does this work? Oh wait, I'm stupid. Just goes in there. Alright. That was a waste of lives. Shit. So I still don't know what they're... Okay, it's eyes and nose color. Okay, that's fine. So now we need to... Okay, well this one goes there then. And then... I need to see if this is by column or by row. Okay, it's by... Alright, cool. Alright, should be fine then. So you go here.
Hey, that's cool. A place for everyone and
Alright, we
everyone
did
in a
it.
place.
What is even going on here? Don't worry about
Strike the
it.
targets one and all, and watch for a pattern on mudball wall.
Alright, well, we'll start at half past, alright? Or, actually, we might start earlier if I clear this level faster, but, Dun, dun, dun. I want to play Zumbinis, okay? So, no! I said red! Oh, gosh. Okay. Okay, so color is by row, and then the symbols are by... Oh, I should probably... Okay, so I actually don't want the other colors anymore, and it's just I want nice. Dun, da, 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 da. Lame. Okay, alright. Let's make a bet on that. Sad. Literally the only one that didn't. Okay. Alright, what are... So I want... Square's not great. Actually, square might be great. I don't know. Nice. Okay, good. Okay. Lame. Okay. Square, triangle, star? I guess they're equally likely to be star. Nope. Wow, this run is really not going well. My RNG skills are really not amazing. Okay, green. Shit. I only have one shot, huh? Oh no, it's actually a uniquely green square. Okay, never mind, we're fine.
Well done!
Okay. Okay.
Ah, almost out of the woods, shall we say? Get them through the next part of the journey, and these zombies...
Okay, cool. Yeah, I'm gonna need to feed another set through. Okay. Yeah, I lost one at the fleens. I'm so sad. Maybe I have to actually like work out the fleens instead of just like crossing my fingers. I didn't realize there were so few errors allowed. You get like one error. It's like oh so hard. Whatever. Okay. All right. So what do we have so far? We have so ba-bum. Mother freaking. All right. Let's see. All right. Okay. Oh, this is not in the tech. Okay, today's episode 115. A real number satisfies a1 equals x for any sequence en. Show that en. I'm assuming this is a finite sequence of real numbers, because otherwise I'm not. Actually, well, actually it could make sense for an infinite. Is that supposed to be infinite? I actually can't tell. Hang on. They're finite? They're infinite, okay. Suppose an infinite sequence of real numbers. X to the n. Yeah. I came up with I don't know how hard. You can suggest it anyways. People might vote against it. And also it might go horribly, but you're allowed to propose it. That's fine. This happened before. Okay, what is IMO 1987? 1. Why does this problem have 3 parts? AN equals... Oh, sorry, yes, x to the n. Ta-da! Also using the American spelling of color. Use mode 2015-4 having at least 2 parts. Well, I mean, it depends on your definition of part. It's just this literally has 3 explicit parts that are like, I don't know. Well, yeah, sure, fine. Also, you should write 1 over phi. What do you mean you should write 1 over phi? Did I not write that? Oh. Did it not? Oh. It didn't render. Okay. Okay, someone also wants an Amy 13. Let me see if it's any good. It's not up yet, huh? Right, because the contest system is a mess, so I have to find it myself. Where is this 13 people want? Where is it? Oh god, it's 3D Geo. Oh my god. Oh god. I don't really want to do this, sorry. Okay, I'll put it up, but like, okay, let's be real. If I put this up, people are going to vote for it just because they like to make me suffer. Also, whoever wrote this post misspelled the word prime. So, let's fix that now. Relatively prime. Spelling. Okay, anyways. Yeah. Okay. Why am I doing this? It's like, this is the kind of problem where I look at it and I'm like, wow, I'm glad I'm a kid, not a kid, so I don't have to do this. Except you all make me do it anyways. Yes, prompt suggestion is still going. You have like 3 minutes, so think fast. Man, isn't there anything good to do? I don't know. I don't feel like I'm super excited about. The fee problem looks okay. Everything else looks kind of. Okay, right when do you have the one you wanted to send? Yes, I'm typing it, alright. You have a 0 indexed array. AI. Is O plus bitwise XOR? Well, this is a math problem like from Codeforces. It's different from like last week where I had to do an actual coding problem and implement a convex hull. And also this problem only has one parameter. All right, good enough. Well, we'll see. We'll run with this. Whoa. Fee. Codeforces. This was 1748 F. Shit! No. Hang on. I missed the Codeforces. There. All right. Submit your votes. Sweet, no rhombus. And at most 400 and I mean okay, guess I'm doing some combos to start. Okay. That was my first. All right. Okay. Welcome back. So we have why is this not syncing? It's a Codeforces problem. So I have an index. I have an initial array which of 2 to the I, and I'm allowed to XOR an element with the. I'll clarify that this is all indices modulo n. And you want to reverse it in not too many moves. So boom boom boom. So let me write out an example or something. So if I have like dun da da dun da da dun da da. Feels like one of those linear algebra things where you have like some set of operations and they commute with each other, or they don't, or they're idempotent. So if let ti be the operation, then every ti is idempotent. I think ti and tj should commute if I and j are not like too close. So it's just, I guess there's a question of like, if I have like a, b, and c, and I do a plus b, c, and then t1, t2, or a, b, b plus c. These two do not commute, right? A plus b, b plus c. Is that right? Oh shoot! Yeah, the screen is way. Ah, yeah. Let me move that up. I'm gonna color these differently so they're a little easier to read. But they have to. There should be a relation. I think I know what it's. XOR with the next value, not the previous. Wait, what? Oh. Goddamn. Okay, fine. We'll write it backwards. It shouldn't matter because it's just reading from left to right, but okay, fine. A plus b, b, c, a, b plus c, c, a plus b plus c, b plus c, c, a plus b, b plus c, c, a plus c, b plus c, c, a plus b plus c, b, c. Right. So there's only finitely many things I can write down. So this is eventually going to loop in on itself, right? It's just a question of how long does it take before it loops. And the answer is 4 iterations. Um, okay, so cool. So the point is we have linear operators, t1, t2 up to tn, such that which are idempotent, and such that ti tj commute if I minus j is not equal to 1, and t1 t2 t1 t2 equals t2 t1. Well, actually, it's easier if I just write it as like t1 t2 to the fourth is equal to 1, I think, which is equivalent to that relation. So if I do this operation, 8 times that's itself inverse. Yeah, okay. So you can take this picture and draw it like that if you want. Shit, no, wait. Sorry, this is the wrong picture. This is just they're just equal, and then each of these arrows actually goes both ways. Okay. So now the next question I have is, why does this look so familiar? I swear I've seen something exactly like this before. Let me see. That is a horrible way to switch two variables. Okay, but okay, sure. Okay, yeah, the reason this looks so familiar is that if you replace the 4 here with a 3, it's actually the symmetric group has a presentation that looks something like this. That's probably not really the direction I want to go, but I think incidentally, if n equals, hang on, yeah, you have cyclic thingy. Okay. Yeah, the 2 to the I almost feels like it's kind of a red herring in the sense that I'm working with an F2 vector space, and you should just treat the initial elements as any linearly independent ones, and you want to reverse it. So I think writing it in terms of ABC like this is correct. Mm. Actually, n squared is kind of tight now that I'm looking at this. Well, yeah. Reverse feels like it's a little artificial because it doesn't respect the cyclic structure. Like, there's no particular reason why reversing it should be a desirable end goal or something. Like, it's not a particularly natural end goal. Can you do... Yeah, I had the same thought. So we can... So we saw that in 4 moves you can go from like ABC to A plus CBC. If n is even, you can use 4 steps to do... Oh. I see, yeah. There's actually... Okay, yeah. You can actually just treat them separately. So if n is an even number... okay, that makes sense, actually. Wait, is it even or odd? Okay, wait. If you have a, like... If I have this and I like look at just these, then in that's too slow, I think. It's like in like wait, hang on. Yeah, this is too slow. If it takes 4 steps to travel 2 distance... It takes 4 steps to travel 2 distance. Because this is probably the fastest way you can get A plus C. I don't think you should be able to do it faster than that. Actually, now that I think, so when n equals 3, if you just do this, for n equals 3 in particular, if you do A, B, C, you can go from 4 moves to A plus C, B, C. So you can do another 4 moves to get from A plus C, B, A, by doing the same thing backwards. Doing the same thing backwards sounds really stupid, though. Isn't that... Wait, hang on. Wait, what's going on? No, hang on. It's not symmetric. Oh, shit. It goes left. Oh, crap. Okay. Alright, that's actually really annoying. Right, okay, it's not the same from left to right. Like, it's harder to get to A, B, A plus C. Wait, actually, that is really strange. It's like if I have a long sequence, like A1, A2 up to N, and then it takes a really, if I have a really long sequence that goes like, I don't know, A1, A2, and like AK, AK plus 1, AK plus... It's really hard to get this AK onto here. Like, getting from here to AK plus 1 will provably take at least N moves, because you need to push the number all the way through the back before it's even read. Which is not amazing. Right. So, okay, this part here doesn't make sense. Mm. Uh. I really want to... I'm going to read a bit about Coxeter groups. I'm curious now. I do not know. It's okay. I don't know any of it either. But basically, it's like I think I think I've seen this before somewhere, and I think you can explicitly classify. I'm not sure about this. But I feel like I should be able to. I feel like I should be able to characterize all obtainable arrays. Like, so the goal array is a reversed array, but I feel like you should be able to classify them all. So I'm gonna read a bit about this nonsense. So in our example, the Coxeter matrix, okay, the diagonal entries are all 1. The non-diagonal entries are either 2 or 4. They're 2 close to the diagonal, 4 off the diagonal. Which means that okay, so these are all the Coxeter diagrams. So for us, the Coxeter diagram, the Coxeter system generators R1 and A1xi3. Blah 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 blah. Okay. Blah, blah, blah. Okay, so the finite Coxeter groups. Wait, what the hell? Is this could better be finite because it acts on. Are there relations I'm missing? Shit. I think there's relations I'm missing. These are the T1 T to the 4th equals 1 is not the only non-trivial relation. Is that what I'm understanding? Because the Coxeter groups of finite size were explicitly classified. Blah 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 blah. I want. Okay. Alright, I'll stop goofing off. Okay, so what that very long detour did was tell me that there's relations that are other than T1, T2 to the 4th is equal to 1 among the TIs. Because otherwise, the random Wikipedia article I just read tells me that the group you get out of this is not finite, so it's not the one we're looking at. Yeah, thank you, Alti Swift, for the follow. Okay, okay. Shit. Reverse is such a weird goal. Why would you want to reverse? The thing about like the thing the numbers at the endpoints are kind of sad because the operation's only going in one direction. Um, yeah. Uh, Man, I really wanted the TI thing to. So there's some theory if you actually do have a Coxeter group, which I think we don't here, until I find some other relations. Um, but there's a thing called a length function, which gives a so-called Bruhat order. Oh man, how are Dinkin diagrams relevant? Well, I mean, my point is that they're not. So, like right now, I have these n operators that satisfy certain relations. And if these were the only relations, then the theory of Coxeter groups will apply to tell you that the set of things you're moving around is a Coxeter group. And for every Coxeter group, you attach a Dinkin diagram to it based on whether Ti to the Tj, like the order of Ti Tj. And Dinkin diagrams are the... Sorry, what am I saying? Sorry, Coxeter graph was the word. You draw a Coxeter graph corresponding to the group. Like, for example... I don't know. It's like these thingies. These things are called Coxeter graphs. And there is a classification of which Coxeter graphs correspond to finite Coxeter groups, and those are Dinkin diagrams. I agree it would be overkill if it worked, but my point is that it doesn't work because the diagram that we get for our group, if these were the only relations, is a cycle with 4s labeled on all the edges. And that's not any of the Coxeter graphs in this picture. So because it's not a Coxeter graph in the picture, these can't be the only relationships because we know our group was supposed to be finite, like the set of states we can reach. So there's additional relations. That's the very long. If we actually got something that was in here, then I could solve the problem by looking up the size of the maximal Bruhat order, which actually would be about n squared, so it's like the right order of magnitude as well. But this is not the situation we're in, because wait, actually, what's the product of a Coxeter group? If you take a group product, oh yeah, the diagram just looks like a bunch of disjoint parts. Okay, fine. All finite Coxeter groups arise this way. Yeah, alright. Sad. I really wanted to bring a sledgehammer to the table. So, in that case, what's the relation? I'm being told there's like an extra relation, but I don't see where it's coming from. But like, for example, when n equals 3... Okay, well, what did I learn when n equals 3? When n equals 3, if I apply t1, t2 2 times, I get to a plus c, b, c. And then when I apply t3, I get a plus c, b, a. And if I apply t1, t2 squared another bunch of times. Yeah, so there's definitely more relations, right? Like, it's just, I haven't found all the relations yet. If there was ever a hope of doing that to begin with. Where, yeah, this is CPA. Which particularly means, like, this is an algorithm that gets n equals 3 in 9 turns. Which is within the time limit, so... Yay, question mark? I don't really know. Yeah. Wait, actually, I'm a little confused now. Did I screw up? Because this... If this is a thing that swaps A and C. So in theory, if I do it twice... It should... Yeah, all these arrows go both ways. Okay, so this doesn't give me any new relation on T3, does it? Yeah, this gives me no new relation, actually. Well, I was hoping this would give me a relation between T1, T2, and T3. Yeah, I think the closest thing I have to a foothold is that this operation is really easy to describe. It's like, go by 2 instead of 1. Okay, actually, so in that case, can I go by 3 easily? Oh my god, I really wish this was not... okay, I'll get to what Warren said in just a moment. I want to see what happens if I do this. Say b plus d, and then I can go 1. And then... I feel like this is too slow. If I'm only... Actually, maybe this isn't that slow. It's still kind of slow. So I can go from... I can add by 3 slots away in 7 moves? But this is gonna be exponentially long, right? This is not a fast process. Actually, is it? Wait, no. It might be... Wait, actually it might be linear time. Hang on. Hang on. So if I have... Is it like 3k plus 1? Oh, okay, never mind. Like if I have A, B, C, D, E, right? What we saw is that in 7 moves I can do B plus C, C, D, E. No, shit. I fucked up. This is 4. Yeah, so this is gonna be exponential time. Yeah, never mind. Okay, Warren had something. A plus B, B plus C, C plus D, D plus E. So you start with A, B, C, D, E. And then you hit. So this takes 4 moves. And then... some sort of binomial coefficient. Yeah. So if you do the same thing again, A plus C, B plus D, C plus E, D, E. Yeah, if you ignore the mod 2 part, they are actually just... They are literally binomial coefficients, right? Like, if you ignore the mod 2. So... Yeah, they're actually literally binomial coefficients. If you can do... Okay, if you can do that, then you just do... Wait, did I not try this earlier? I thought I tried that. Like, for example, we're given 1, so we can... Yeah, I'm assuming that's K and it's not N or whatever. Yeah, didn't we agree that takes exponential time? I feel like... Oh, actually, no, it might not. If I can update by... Okay. So like we know how to update 1 away in 1, so I can update 2 away in 4 steps. So I want to update 4 away in 16 steps, so I can update. Yeah, sorry. You're. Wait, I swear I thought that God. Thank you, Gabriel, for the follow. I swear I got exponential timer there. It sounds like I feel like you're right. This feels like it's taking quadratic time. Okay. Okay. Let's do the. I think this is called the master theorem or something stupid like that. Okay then. Moving on. So, I just feel like it's such a weird name for the like. It doesn't tell you what the theorem does, right? It's just called the master theorem. And it sounds really cool until like, I don't know. So if I have a thing that's oh hell, we'll call it X, Y, and Z. All right, and we have a way to update in P. So like f of P or whatever, Y plus Z. So this is distance P, this is distance Q or something. Z, X, and then X plus Y plus Z, Y plus Z. Yeah, so this is the thing we were doing earlier, and then this now you have Y, and then okay. So like f of P plus Q, or f of n is at most max, min of P plus Q equals n of f of P plus f of Q. Actually, I should. Well, depending on how you define f. Let's just say define a function f by this. And then the question is, how fast does f grow? And yeah, this is where I just look up what the master theorem says because I don't really want to work it out now. Oh, also f of 1 equals 1. Sorry, there's a factor of 2. 2. Okay. Okay, master theorem CS. Recurrences of okay, blah, blah, blah. Basically, it's like this will do the induction for us, and I don't. Where does it tell us what the theorem says? Blah 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 log b. Oh my god. Wait, this is like. I wonder if I should just work it out myself instead of trying to look it up. Okay, come on. Like. Okay, well, we'll be mathematicians and work out the exact values. F of 1 is 1. F of 4 is... Sorry, F of 2 is 4. So F of 3 is like 12. But F of 4 is... It's in the master theorem bound column. Yeah, but see, the other thing is I actually care about what the constant is in front. Like this gives a theta bound. So you know what? It's fine. We will just actually compute. Why is f5 larger than f of 6? That's... Wait, that can't be right. No. This function better be monotonic, right? F of 6 is 48. Oh, wait. Is this like 1/2 n squared-ish? I can't... that feels a little too good to be true. Wait, okay, well, you know, I'm just gonna compute this and look up on OEIS because I'm lazy like that. 56. It is 64. Yeah, okay, but it's at least quadratic, so it's like in a reasonable ballpark. Oh yes, org 1, 4, 12, 16, 32, 48, 56, 64. What do you mean it doesn't match anything in the table? What? Seriously? Did I miscompute a term? No. Oh, yeah, I miscomputed a term. 4 plus 1 is in fact 5 and not 6. So this term is screwed. Borked. Oh, jeez. Alright, that means all of these are borked. Okay, 5 is 10, 14, 28. 6 is 40. 52. Hey, are you allowed to look up OEIS in Codeforces? I actually don't know. Are you doing Math Olympiad? Yes. Huh. Okay, so there's an explicit... Wait, people actually do this? That's beautiful. Okay, if f of n is 2 to the k plus r for 1 less than r less than 2 to the... sorry, 0 less than or equal to r less than 2 to the k. Then this is equal to 2 to the k times n plus 2r apparently is the explicit form. So there's like some penalty or something if... Well, it's just like pretty close to n squared, right? Is that a true fact? If I let r be like 2 to the k minus 1, 2 to the k. Like I can't tell if this is just n squared. What is n? Frick. Sorry. Yeah, I keep using n for like the input here. We'll call it like, I don't know, a or something. So r equals 0, then it's actually exactly a squared. And if like it's like 7 or something. It's pretty close to a squared. I think definitely always less than it. Is that true? You don't read my long messages. I mean, mostly because I don't really understand them. Just saying. They appear to be above my pay grade. Okay. Yeah, but it's like, I don't know if this is where I want to go anyways. Because even if I can do this, like, if I can do an addition that's far away and if it takes like n squared time, 3 has n squared becomes really tight, right? Because you have like n things to do. So I'm not sure this. I think it's good to know that this is possible. I'm not convinced. I'm actually optimistic that will. Yeah, I'll give a cubic. Yeah. Yeah, no, it's definitely quadratic. I was wrong earlier. For some reason, I thought it was exponential. I don't know what I was thinking. But yeah, it's not. It's too specific. Like we have a lot of numbers to change, so I need to do something that actually takes advantage of the fact that we're doing a reversal as a final goal. Yeah, like the binomial coefficient theme from earlier felt better, actually, honestly. But I just don't know. Could you perhaps induct using this? What does induct mean here? You get the fight M. You get the right A0. I got the right A0, really? What does that mean? So if I do this operation... Wait, I don't even see how that... Oh, I see. You want to get A0 and then reverse everything else. Feels kind of crappy. Right, because if you update A0 so that it's equal to AN after a lot of work, wait, is my... Hang on. Okay. Yeah, I mean, what you can do, you can imagine doing something like, I don't know, you have A0 up to... I really wish they used capital N for the... Whatever, it doesn't matter. A minus 1, and then you do, like, about n minus 1 squared-ish operations to get an minus 1, and then a1, you know. Okay, and then you bop this A0... And then you do like another n minus 1 squared-ish operations. It's like n minus 1. So in that way, you can, you know, toggle like this. We've toggled these two in 2n squared operations. The problem is this is too slow. We know the task is possible, but this is going to take n cubed time, not just n squared time. Do you want a hint? Do I want a hint? I want a nuke. That's really what I want. What is the maximum length of a Coxeter word? No. It's definitely, it's infinite for an infinite Coxeter group. That doesn't matter here. It's just there's some other relations besides the. Yeah, I think the crux of this is mostly me goofing off. I don't really. I think like because there's additional relations that I don't know what they are. It's just not gonna help. Um. What was the thing we were doing earlier with like the binomial shit? I don't know. Reversing is such a weird target. I can't get over it. N equals 3 took us 9 moves, right? Yeah. I feel like I'm in a situation where like I should just try some stuff and see what sticks. Because I feel like if I'm in a free situation where like there's no way I can really narrow down what set of things I want to try next, and I should just like throw some crap at the wall and see what sticks. I'm assuming it's construct. It might not be constructive actually. There's a chance that what you do is you write down any sequence that works, and then you try to do a reduction argument where like, if the word like you write in a sequence of valid operations, and then you try to do some sort of reduction on it, using I don't know what that would look like though, because I can't really tell what the sequence looks like for, say, I don't know what. Also, I'm a stupid head. This is not what you want to do. Even if your goal is to actually wait, hang on. N-1 is no. Yeah, that's a problem. I'm not good. I don't like free stuff. Yeah. What are the relations? Are there other relations in the TIs? Because a lot of the TIs commute. Like even if I crap. No, it's no good. T1, T2, T1, T2, T1, T2. Yeah, it's just the wrong kind of problem. Because I'm like, when I'm on stream, I like am more adverse than I am in real life to like trying things without knowing it. Like having some confidence ahead of time whether it'll work. Just 'cause if I try a thing and it doesn't work, then it's like does not make for great entertainment. But that's what you're supposed to do for this problem, is just try some crap. For n equals 3, are there other like if I have just T1, T2, T2, oh, that's crap because it loops around anyways. 1331, 14641. Okay, so here's a thing from earlier. I need to be moving the numbers simultaneously because I won't fit in the time limit otherwise. For n equals 3, that's basically it. Okay. So every n-1 operations, I can get a certain binomial coefficient thing. So this is like a0 plus a1, a1 plus a2, and so on. An minus 1 plus an. And this is like an. Then when it's like 1, 2, 1. If I did this, say like, so Pascal's triangle gives even binomial coefficients on powers of 2. So for example, if I did this a(n-1) times, what I would be able to get is a0 plus a8, a1 plus a9, up to like a(n-8) plus an, and then everything after that would be the same. Am I going anywhere with that? This one is awkward because it doesn't loop, is the thing. I'm not looping when I do this. What happens if I... Oh, but it screws with the binomial, so like if I try to make it cyclic, then I can't actually compute what's going on. Okay, but okay, let's imagine we're in a really beautiful world and like capital N is a power of 2, okay? And we'll try to do some garbage. So I'll even be concrete. Let's pretend that N equals like 8. So if I do this stupid Pascal thing that I described, then what I end up with is A0 plus A4. It's effectively a way to do the thing that we were doing before, but simultaneously. So in shit, how many moves is this? It's actually 4 and -1. It's not even that long. 4 and -1 moves. A2 plus A6, A3 plus A7. And then, you know, these guys don't change. And then because we live in a cyclic world, I can do the same thing again, and that'll put me at A0, A1, A2, A3. Yeah, this feels much better. A3 plus A7. And then, I should have these in blue, actually, they don't change. We'll use blue for stuff that's not changing from the previous line. A0 plus A4 up to A3 plus A7. And then do it again, right? So green, red, green, red. So in total, in general, I guess if n is like 2 to the something, then this is an algorithm that will do the correct job in 2 to the e minus 1 times n minus 1 times 4 steps. Wait, is this still not in the time limit? Oh, Jesus Christ. This is 112 steps. For n equals 8, I need 96. Really? This doesn't fit? I mean, at least it's quadratic now, but... Really? This isn't fast enough? Wait, I have a hard time believing that, actually. Did I mess up? No, this can't be true. Is this 4 and -1? How many steps am I doing to get this to work? No, I should hold A4 and then only do the thing here, right? I don't need the other crap. Do I? No, I need A7. God damn it. Really? This doesn't finish in time even for a power of 2. Because what I thought was going to happen was you can do it for like this, and then you have to like do some work to make it work for any n. But this doesn't look great. Shit. Oh no. If I can't even do it for a power of 2, I don't know what I'm gonna do in general. This feels much like I got the binomial coefficients as a way to not make a mess. When I'm crap. Wait. I really don't believe this. You're telling me if I do this for n equals 4, it's going to take more than 24 turns? I find that really hard to... It can't take that many turns, can it? Am I crazy? I'm going to actually write it out. Like, if I mess this up because I If I throw this approach out because I failed at arithmetic, then it's... This cannot work as it is inefficient. Thank you, Dotted, for the sub. 18 months. You're trying to do just one operation, which means you are also fixing everything else. Wait, actually, I don't see what that means here. No, this is exactly right for n equals 4, right? This got me the exact number. What am I doing? Hang on. 6, 6, 4, 2, 6, 6, 7. Wait, am I crazy? Hang on. Is this n minus 1 or 4 or... Hang on. What is going on? Wait, I got the exact right count for little n equals 4. Right? This is exactly right for little n equals 4, right? You do a plus c, b plus d, so this is like a 6-step algorithm, and then you do it 4 times, and that gives you exactly 24. So how did I fuck the... When n equals 2 to the e... I guess it's just because n minus... Okay. Alright, fine. It's because when capital N equals 4, n minus 1 is actually... 3 is actually a lot smaller than 4, so it's okay. But when n equals 8, it's not okay anymore, I think. When n equals 8, it's like you do 28 times 4 is 112, and your time limit was 96. Okay, fine. Fine. On the other hand, I got exactly the right number for n equals capital N equals 4, so I still want to think about that. Anything can be done on the numbers in O of n squared. I'm not sure what that means. Oh, wait. Also, this doesn't actually do what I wanted to do. This gives me from ABCD to like CDAB in 24 moves, right? If I actually do this. Yeah, this gives me the CDAB, which is actually not what I want. That's not reversed. Shit. Oh, I hate those. Sorry, I get to CDAB in 24. Okay, you know, I get CDAB in 24 moves. Let's then. Okay, how long have I been smashing my head on this so far? Maybe see if you just swap two elements. We already know how to swap two elements. It takes too long. We can swap two elements in O of n squared time. But the problem is there's n over 2 pairs to swap. Yeah, okay. Man. I'm so excited about the binomial thing. There's so many there's too many possible algorithms and I can't narrow any of them down. I'm trying to imagine a situation where if I take a binomial, yeah, no, it's the binomial thing just doesn't work. Okay, yeah, that's fair. Yeah, it's you actually just need to do the motions, like there's like this kind of motion where like the coefficients move like towards the left, and you actually just need to move everything at once, because if you do it one at a time, you will not fit into n squared time. But then it's just so much garbage to deal with. There's so much stuff. How are you feeling about? Wait, is that true? Or I thought like I was of the impression people were only giving me the ones that were good math problems, with the exception of like the two that took me a really long time to implement. Yeah, yeah. A good number are like this. Okay, huh. Maybe I should try to do more Codeforces then. Tourist. H2. Oh no, more Codeforces. What is this? Oh god. This window signals thing does not look very easy. Oh, there's at most 2 broken windows. Okay, that never mind. I'm a little less scared. K is at most 2. Okay, that's a lot less scary. Window signals is me. A B B C C D D. Yeah, I mean it's. What? Uh. Bleeding polygon. Oh, that's beautiful. I should just throw stuff at the wall, right? Man, I just don't like having RNG. I never liked free. Okay, so if A plus B plus C, C plus D, D, and then what if I just do? I need a factor of. I'm just gonna try some crap. B plus D, C plus D, D, if I do like the staircase-like thing, though that will take a total of n choose 2 moves. When I do a staircase like this, what happens? So what are the coefficients, I guess, is the real question. And okay, these are also binomial coefficients, right? This is 1, 3, 3, 1. Like this comes out of 1, 3, 3, 1. 1, 2, 1, 1, 1, 1. So that's not great because binomial coefficients are kind of complicated in mod 2. It's not. Well, it could. It's. Nah, I don't like it. Can you try the opposite way and prove that it takes all of n squared steps? No. No way, right? Inversions? I feel like inversions, does that make like, what would that mean? What's the stupidest way you can reverse an array? What does that mean? Like, the stupid way is to switch the elements in opposite pairs. Simplest. What does simplest mean? Like, do that. Didn't we already agree that takes n cubed time? With the method you had, yeah. Well, I mean, the point of the method, the dumb method, is that, like, my brain has linear memory, not quadratic. And I, like, really didn't want to deal with having lots of coefficients. So I was like, if you do the sequence of moves that lets you swap two elements without hurting anything else, then the things don't run into each other. Yeah, no, I like, you can swap two elements in, like, quadratic-ish time. And then... Okay, you can swap two things in quadratic time, and then, like, I don't... Oh, are you fucking... Does that actually finish in the time limit? Also, isn't that literally what I was doing with the CTAB garbage? Well, that's literally what this is, right? How do you swap each element with a 1n over two elements later? Okay, wait, hang on. Wait, I feel like this was this not what we were trying and concluded it didn't work. I'm like swap each element. So you do a global. That was the n over. Hang on, I think I'm not understanding that hint. Um. G B C D E F A. I'm so confused. Um. Alright, so here's ABCDFG, and you're telling me that I want to. I mean. Wait, I'm really confused. There's no way you can do it in. Can you? Can you do this in like linear time? Because we computed earlier that it's like. Are you giving me 7 because you want me to do 1, 2, 4? Like. And then. Wait, shit, it's not. This is. No. It's 1 away, 2 away, and. Fuck. 3 away? Something. I don't freaking know. This is. What was it? I mean, also it doesn't matter. Like, it's just not gonna finish in time. We agreed this was like 10-ish moves. We had f of 3 earlier. Yeah, this is 10 moves. And then you do the same thing here. 4, and this is 1. Or something like that. I don't know. Is this 20? Oh, that's the thing we got earlier, right? 6 steps away. Or 40. Wait, why is it 40? I don't know. Honestly, yeah. I think that's the thing about the free stuff. Is like when there's just like the machines can try random crap faster than you can. And then you can just try to engineers induct. Right? It's just like there's this big search space and you have no good heuristics for which things to search for. So you just try a bunch of them, get the data of which things do work, and then try to analyze the data or something. In my ideal world where reinforcement learning is something I actually knew how to do. Yeah, I just don't get the hint. Like I feel like you're telling me to do the thing I already tried. So that means I'm missing something. There's something I'm not quite doing correctly, but I don't know what it is. Oh wait, this is div 2. Oh no. Uh, uh, uh. How did you swap F and G in one move? Wait, oh sorry, I'm stupid. Right, we agreed this was, yeah, everything's off by a factor of something. I forgot what that factor is. Hang on. Wait, yeah, my recursion's completely screwed. Wait, okay, sorry, what am I doing? What was I trying to do? I forgot. I'm too old for this crap. I think I've been looking at this problem for too long. I have forgotten what the statement actually said. But I will say, I think the fact that you're telling me this is div 2 puts like an upper bound on like the Kolmogorov complexity of the solution. It's like that thing where like sometimes you get like these IMO 1-4s that are way too hard for the position, but if you tell someone it's 1-4, it rules out a lot of possible approaches that you would normally consider for like a 3-6. It's sort of like that cars problem, right? Like TSTST 2019-3, where like that problem deserves to be a 3-6, but if for some reason it got put as a 1-4, it would tell you that you're not supposed to do a really deep induction. I don't know how much of the other stuff you had will help. Okay, sure. Div 2F can be like 3000. I don't actually know what that means because I haven't done Codeforces in like... I did Codeforces once, and I got 4th in some Division 2 contest, and then I like never participated again. So I don't actually know how any of the ratings work. CF rating ranges. Oh, the problems have a rating in addition to the humans. Is that what's happening? Okay, so the problems all are also rated. I see. I'm Interesting. Okay. Which problem is this? This is oh, I didn't ever put the problem number in, huh? Let me do that. Where did the problem number go? Didn't I write it in here? 1748F. Yeah, but I... The frick? Okay, I figured out how to swap two elements earlier, and I forgot how I did it. But I might have miscomputed F1 now that I'm looking at this, because it does not, you cannot swap two elements in one move. So what was the definition of F? can go from 1, 2, 4, 2 to the n to 2 to the n, 2, 4, 1 in O of n time. So you're telling me I can actually do swaps in linear time? Seriously? Perhaps. But I had quadratic time earlier. Well, okay, I don't know anymore. Then I'm just confused what I was doing earlier. Because, like, if you can swap in linear time, how did we not notice that before? You can swap two numbers in 2n time? What? Excuse me. Plus CC plus... What? How do you swap in linear time? What? How do you swap in linear time? Wait. This is not cool. What? I need to go it out by. Okay. You need to do it 3 times. I'm so confused. Six is such a big number too. It doesn't print new lines in chat. So that's the okay. It's like B, C, D. C, D, and then A, B, dun 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 dun. So what do I... Wait, hang on. Nose was a mistake. You have learned well. Um, wait, what am I? So wait, so how do I do it? Do I keep doing the same sequence? So then I get C. Or no? Do I? Okay, wait, hang on. I'm gonna use green dots for the operation. Green, green, green. You want me to go backwards like that, and then B, C, D, and then A plus B plus C plus D. So you can push all this junk onto one of the variables, and then operate one more time here. I think it's A plus B plus C plus D, B, C, A plus B plus C. So we have one, so in, okay, this is the 2n that we were talking about, I guess, or 2n minus 2, I guess. And then if I apply this again, alright, I need to actually, so what this operation does is it replaces, okay, I need to make sure I don't mess this up. The sum of these three things is A plus D. And then these don't change, these don't change. And the sum of everything on the board is B plus C plus D. And I do the same thing again. So the sum of these things is D. And the sum of everything on the board is... Wait, I just got the same thing back. Okay, so that's not what I was supposed to do. Ti squared is 1, right? Item... Wait, is item potent the wrong word? Shit! Sorry, yeah. Sorry, what's the word for when something squares to 1? I forgot. Which... I'll just write Ti squared equals 1. Involution. Okay. Yeah. Yeah, item potent is x squared equals x, I think, right? Yeah, x, yeah, okay. Okay, so I just got back to ABCD, which is really not what I wanted. Hang on. Goddamn. What? No. Like this is, so I did the zigzag thing, right? Like this was one. How to learn this stuff? I think you are assuming that I know what's going on, which I don't. Yeah, this is, apparently this was some Codeforces problem recently, and it's like, not only is it hard, it's also the kind of problem I'm not good at. Because the kind of math problem I'm good at is the kind where I can like narrow down approaches really quickly. And this is like the opposite of that, where there's like no constraints I can put on what a reasonable approach might look like. Wait, okay, yeah, okay, it is unchanged is another way of describing it. Wait, what is this watermelon problem? What? What? You should do watermelon live on stream. I mean, okay. Yeah, okay. I'm gonna consider this problem as not solved because I am not getting. I've taken enough hints that it's not a clean solve anyways, and we can do the watermelon instead for comedic value. So, and we're gonna pretend like we are wait, where am I? Okay, well, we're going to use this as an excuse to use our competitive programming template that I wrote. This is such. Okay, dot files ioi template dot cpp watermelon dot cpp. Okay, so cin int w wcn and no, that's not how cin works. How do you read input? cnw? Yeah, okay, cool. Okay, if w equals 2, return cout no and l. Else if w%2 equals 0, well, else cout yes and l. Okay. Four test cases should be enough, right? Still. Wait, how? No, yes. Okay, beautiful. I forgot my Codeforces password. I don't know if I ever... Hang on. Yeah, I initially misread the problem as saying they just wanted it to divide into 2 equal parts, and I was like, what? But okay, do I have a Codeforces password? I've logged in before, so I should have a login somewhere. I just don't know what it is. Okay, I successfully remembered my password. Yeah, what I was gonna say is that I don't feel like you should wrong answer case 5 because I feel like this problem is so easy that like you know that there's the fact that they're giving it to you, I think should tell you that like, you know, there's at least one case that might not be completely stupid. Maybe, I don't know. Maybe I don't know. Oh, that's not. Oh wait, shoot. That's the wrong version of C, isn't it? Which version of C am I supposed to pick? C. What is the difference between all these? I don't actually know. Accepted. Okay, cool. Yeah, no, I have a password manager, but it's not on the. So when I do streaming, I use a separate user account from like my day-to-day work, so that because I'm really afraid that one day I will like open my PDF viewer and they'll like go to like the most recent document or something, and I'll like accidentally leak the TST on the stream or something stupid like that. So the account that I use for streaming is kind of quarantined from all my important things like passwords and so on. Yeah, and yeah, the reason I muted it was because I don't know. One day someone is going to like figure out one of my passwords by listening to the sounds that the keystrokes makes or something. I swear to God. Um, all right. Wow. No, okay. People are just giving me Codeforces problems now. All right. What else is happening? You have an integer and how many cover felt like. Okay, wait, there's like, okay, so that and what else was I given? 70C. Uh, each test consists of multiple test cases, blah, 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 blah. Positive. X positive doesn't matter for the GCD thing, right? Alright, do I do diamonds or then an NT first? Evan, diamonds is 1 minute. NT is brain. Okay, I'll do diamonds. So wait, is this 1 minute? I thought this was gonna be like a Fibon. Okay, wait. So boom, 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 boom versus. Oh. Okay, I understand why this is 1 minute. Oh, fuck. I might miss an edge case. I'm sorry if I do. Actually, can I just do? Oh no, it starts with a number of test cases. Okay, never mind. I was gonna see if you could do like C in to C out, but so it's very sad. And C in, or sorry, C in and C out and ed wide. Oh wait, let me actually verify this is correct. I think that should be it. I don't actually know what version of C++ I use. Can someone tell me? So I GCC 12.2.1. You know what? It shouldn't matter, right? I just pick one. Yeah, whatever. Wait, I probably should actually test to make sure this works. Okay, cool. Fine. That's the compiler version, not C++ version. Use CPP20. Okay. I'll just pretend I know what that meant. Okay, actually, I should figure out what. Oh, that's the compiler version. I see. So this 12.2.1 is ahead of this 11, but G++ 20. Okay. Wait, I don't remember what compiler command I gave for my debugger. C++ 17. Okay, so I should use 17 for consistency with my computer. Got it. All right. Anyways, wait, no template. Okay, what was the vector? There is an abbreviation for vector int. VI. I already forgot how you create a vector. Okay, wait, I need to look at what I did last stream. How do you make a vector? So v dot clear. Okay, so T is uninitialized. Oh, right, I should probably read in T. C in T. For in, okay, and then we read in N. For in J equals 0, J less than N, J plus plus. Okay, I know how to re-input. Very cool. Do I need a dummy variable to hold the AI? Cin AI. V dot push back AI. Okay, cool. Anyways, right, what was I supposed to do here? So the Chinese remainder theorem says I need to be able to, okay, AJ minus AI, right? Let's see. So you don't need to clear. Yeah, but I'm reusing the vector, right? Because there's like multiple test cases, so I need to clear it, question mark? This is 1770C. Okay, sure. We'll change the names. This was 1770C. What was the other one? I already forgot what watermelon was. 4A. Okay. And then diamonds was 1339A. Okay. Kappa. Right, okay, so this is... Yeah, I don't know. I feel like I was told when I was a kid that you're not supposed to initialize variables inside loops. I don't actually know if that makes sense here. Like, if I do VIV in the loop, is that bad? But it feels kind of bad. I don't know. Alright, so what was I supposed to do? So for I want to GCD AA plus X and AJ minus AI, right? N is 1,000-ish. So I can do up to n squared. So okay, first I'm gonna sort. V dot sort. Is that a command actually? I don't know. V dot sort. No. How do you sort an array? Sort V? Sort. Oh, sort v dot begin, v dot end. All right, beautiful. You can tell how much experience I have. Just types exact. Modern C++, you should always initialize where you want. Okay, so we're just gonna initialize it here then, and then all right, I will learn good practice. Where is this better practice? I actually don't know. Wait, so when I reinitialize like this, it clears the existing value. Is that correct? Okay, okay, first I'm gonna make sure that the numbers are all distinct. So k plus plus if v dot v dot at k equals v dot at k comparison of int and stand vector long unsigned int. I think I ignored that warning, right? Okay, so shit. Okay, I'll put it in a subroutine. Int test case and viv, I think. So test case v and is it and v or star v or it's and, right? I think. No. Star? Is it star? Is it? You just try all the syntaxes until the thing doesn't complain. Is that it? Probably your template has sort. I don't see a sort in the template actually. Yeah, I don't actually see a sort. I feel like there should be one in. Oh, it's just V? Okay, cool. Well, alright. So we're gonna see out test case. Actually, hang on. Sorry. Bool. This is bool. Yes. No. Okay. Okay. All right. So what was I? For int I equals 0, I less than v dots. If v dot at I equals v dot at I plus 1, return false. Okay. Then if they're all distinct, what I need to make sure is the. Wait, do I need? Wait, this goes up to 10 to the 18. God damn it. Vi vector int. Do I not have vector int 32 or int 64 or something? Does my template not have this? Long. Okay, fine. We'll vector int 64. Oh god. All right. Test case vi vector int 64. Okay, cool. What was I doing? Okay, so then for wait, okay, maybe I should actually solve the problem first. So I'm looking at GCD of x plus AI and AJ minus AI. So you die if and only if there is a prime number p such that p divides AJ minus AI. And also what? Wait, hang on. Wait, does this ever happen? Your template is too heavy. 99% of it is useless. I believe you. I mean, I just copy pasted it from somewhere. I forget where. Wait, hang on. Hang on. So it's you fail if for some prime p there are at least 2 elements of every residue modulo p. That's the condition, right? No, it's not like if the AIs are 1, 2, 3, 4, we can still do if all equal. Oh. Wait, what am I doing? Good point. Wait, actually you can do them if they're all equal. Wait, how? What? If all the AIs are equal? Isn't the GCD just positive then? Like, everything's positive in this problem, right? I don't think this template is that heavy, is it? I don't know. Count. Yeah. Okay, so that's the thing I said, right? Because the thing that... Counts.initial... Okay, wait, how do we initialize a array again? Counts.assign p0 for int I equals 0, I less than v dot size. So actually, I don't think I... No, I do need this check. So counts dot at v dot at I modulo p plus plus. And then for in I equals 0, I less than p, I plus plus, if counts dot at I is less than or equal to 1, then that prime p is okay. So we'll break the loop. Well, okay equals. And then if okay, if it's not okay, then we return false. And otherwise we return true. I think that's what it should be, right? Maybe? I hope? Vector int counts p. No, that part is fine, right? The fail condition should be for every residue class modulo p. There are at least 2 elements in there. Okay, let's test it. Shit. I probably should have put these in different directories. Watermelon was 1313 4, right? Tests 4a 4a CP. Okay, and then what is another test case? Oh shit, I didn't NL. Stop. That's also really bad. Why did it print? Wait, I'm so confused. Alright, what did I screw up? Oh shit, this is... Wait. Okay, that is a mistake. Yes, no, okay. I'm just gonna submit. Boom. Yeah, so there's an AI minus H. Am I sorting after every input? Hang on. AI minus HA. Shit. Okay, yes, good point. Also, yeah, I got a wrong answer somewhere. Okay, let me actually write some test cases. Wait. Am I crazy? Okay, well, first of all, that's too many values, but also, which case? Oh, sorry, yeah, that actually doesn't work. That will fail mod. No, it won't. What point does that fail? Yeah, wait. Okay, that's actually just the wrong answer. Interesting. Wait, how do I use this stupid thing I wrote? Why does the debug function not do anything? I thought I checked this. Hang on. Wait. Oh, no, wait. I'm just stupid. The correct answer is yes. So this was just fine to begin with. However, I also... Oh, right, and then this won't trigger because it didn't trigger. Okay, so what could I screw up? That is the condition, right? Like, it's like for every prime p... Oh wait, I bounded the prime by 1,000. That's not correct. No, because your prime is smaller than 1,000, you won't fill it up. It's int AI. Oh, mother. I feel like the program shouldn't compile. Okay, it doesn't matter. Actually, no, I guess it should compile. I feel like I would have liked to have a warning if I was trying to feed and... Okay, whatever, doesn't matter. Alright, beautiful. For auto X... Oh, does that work? W convergence does it. Okay, we are going to add that flag in and see if it would have caught that. Convert, oh, no S. So if I do in here, will it yell at me? Wait, it didn't say anything. This should fail. Or like the compile... Okay, if I have this flag here, it should yell at me, right? I do have WAll. WAll has specific flags. I don't know what that means. Is this not... Okay, it doesn't matter. I'll take your advice though for auto and X AI. Wait, how does this code work actually? CN for auto XV. CN. Is that? You need to resize V to... Oh, okay. So the way this works is I do V to resize. I don't need to clear here because it's new, right? V size N. V dot resize N. Okay, so the claim is if I do this, then I don't need the resize. F. You should create the vector after inputting N. I did, right? Did I not? Wait. No pushback. Oh, I see. Oh, I see. So this will read into... Oh, okay. I understand. I understand. Okay. Let me verify this works for my educational entertainment. This should work, right? Cool. All right. I see. So that's a pointer. I see. You can get a pointer to everything in... Okay, I see. Understand. Okay, well, that's enough Codeforces for today. We learned how to read input again. I think every time I do this on stream, like the first thing is like I don't remember which way CN goes. One day I will get it without having to guess multiple times. Can I suggest for the next episode? Sure, why not? Yeah, just put a submission in the queue and we'll I don't know. We'll do it if there aren't that many other suggestions. If there are a lot of suggestions, then the people that are actually there get priority. What time zone is this? Wherever you are. Yeah, so I'm in Pacific time. The stream is officially 5 p.m. Pacific / 8 p.m. Eastern for like 3 to 5 hours each. Sometimes it goes longer than 5 hours actually. But okay, I'm gonna. I already forgot. Did the IMO problem? The feed problem got more votes than the IMO problem, right? I think. So we can start with the feed problem. Okay, cool. Yeah, let's do feed. What is the best way to study Oh, it's upsizes. I see. Okay. What is the best way to study discrete math, proving, and logic? You know, I never figured out how people learn how to write proofs. I think like when I grew up, I like read a book that was not terrible, and then that was just fine. Like in particular on my website, there is a big list about. There's this big FAQ about somewhere about how do you learn to write proofs. I think there's like multiple FAQs about it, and then there's some recommendations there. Do I have anything to say beyond that? Yeah, I think I just linked the FAQ. I feel like the fact that, I don't know. I'm going to read it between the lines a little bit, and like when you say discrete math, proving, and logic, I'm assuming you're learning them simultaneously because for some reason people like to learn those at the same time. In which case, the answer is just whatever it was without the discrete math part, just whatever people use to learn proofs. How many Otis shirts do you own? I lost count. Could you sing a song on stream? I don't know. I do think like if you are learning how to write a proof, then having a person who knows what they're doing read it is actually pretty useful. Until you can develop self-sufficiency. However, people who are willing to do that are really rare. Or sorry, willing and able to do that are pretty rare. It's actually really... I don't actually know how you get someone to do this for you. I don't even do it for my kids because there's 350 of them. I just assume they already know what they're doing. Okay, so this is a problem about showing that base x does what you want. Let's see. So you have a fixed base x, which is at least the golden, like 1 over the golden ratio, strictly less than 1. And you have the property that whenever you have a... How much do you check method of MMP submissions? Not at all. I literally just gave up because it was impossible. So for any set of inputs for which x sum xn is 0, blah, 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 and you want an is equal to x to the n exactly. Wait. Really? Actually, yeah, that makes sense. You know. The golden ratio thing is interesting. But it's constrained on the x side. It's not constrained on the a sub n side. So... The thing that bothers me about this actually is that I feel like... Okay, so x is close to 1. I feel like there shouldn't be that many sequences en for which the condition is true, actually. Yeah, that's the thing that bothers me. It's like it... Like, how do you cook up a sequence en? Can you do it greedily or something? Like, so if I start with e sub 1, let's just say e sub 1 is... Yeah. So periodic. I think what you could imagine doing is you like let e sub 1 equals 1 and then then you inductively decide on the values of e2, e3, and so on in such a way that it converges to 0. Let's see. So, oh Jesus. So what do you get? Like, even if I did this though, what do you get out of it? You get So okay, that's probably why I need x to be No. Right. So if you imagine x is 0.1 or something like that, then there's just literally like almost there's virtually no sequences that will satisfy the condition. I think literally the only one you can use is the all zero sequence. So the fact that x is at least 1 over phi is what's promising us that there is like enough sequences en that we can say something about the AI. Because you can imagine what this will come out to is that you get you have an infinite. You're generating an infinite system of equations, and you want that infinite system to have only the obvious solutions. So we get to do infinite linear algebra, infinite dimensional linear algebra. It's going to be great. So the question is, do I need like all the ENs, or do I just need to be able to generate some number of them? So 1 over phi is like... okay. I'm gonna, for concreteness, focus on 1 over phi first. Let x equals phi minus 1. So what that means is like x squared is x plus 1, or whatever. And the upshot of this is that we have this infinite system A1 equals A2 plus A3, A2 equals A3 plus A4, and so on. This is not quite enough, right, though? Like, this does not force AI to be powers of x exactly. So I need to, like, are there more equations I can get, though? I feel like the equations I could write from this are just... equivalent. Wait. Actually, now I'm really confused. How does base b work? Does anyone know? If I have an equation in base 1.618, how unique are the representations? X plus x equals... Oh shit! Sorry, my bad. Yeah, sorry. This should say 1 equals 1 equals x plus x squared. Yeah. I feel like that's the only relations, though, right? Like, if I have en to the xn, I feel like it's the sum of copies of 1 minus x squared. I want to say there are no further non-trivial relations. Is that a true statement? That can't be true. No, here's why it's not true. It's the minimal polynomial, but we're not doing... It's not quite polynomials in this world, right? That's the thing. So it's also equal to x squared plus x cubed plus x to the fourth, and so on. In fact, actually, that means there's a lot of representation. It's like... So examples of representations include, one is this, and it's also equal to x plus x cubed plus x to the fifth, I think. Wait, let me make sure I'm not crazy. No, I'm being stupid again. This is not correct. How do you compute series things? So the x plus x cubed thing is correct, I think. The x squared plus x cubed to the... I think that's not correct, is it? X squared over 1 minus x. 1 equals x plus x squared. No, I think that's true. Yeah, I'm not sure which of these are redundant with which other equations though. Yeah. Anyways, so yeah, I agree it's a linear recurrence, and what that means is if you know the value of A2, you can compute the values of A3, A4, and so on. But then you also have like some extra relationship, right? Like you know that A2 plus A3 plus A4 and so on should be equal to hang on. I really wish this was zero indexed. uh Anyways, okay, so but yeah, because it's a linear recurrence, if a1 equals x and a2 equals y, then you know a3 equals each term is the difference of the previous two, so y minus x. A4 would be like redundant means that you can derive it from the other relations or something. Like I could write actually, that's a good question. What do I mean by redundant? Okay, yeah, that's easier actually. An equals like some constant x to the n plus. Actually, I feel like we have one few. Oh no, that's correct. It's just Okay, I shouldn't call this y then. I should call this like. Oh, y is fine actually. For some constants x and y, do I want to solve for these constants? Okay. I don't know if I want to bother chasing the rest of this down because we need to solve the problem much more generally later anyways. But this should work, right? Because you can solve for capital A and capital B explicitly in terms of x and y by solving the resulting system. Then you plug in like the quote-unquote x relation that a1 is equal to a3 plus a5 or whatever. Or actually, sorry, a1 equals a3 plus a4 plus a5 plus a6 or whatever is also a true relationship. X and y are roots of the characteristic polynomial, not the initial values. Oh. God damn it. Yeah, sorry, you're right. I just don't want to deal with it, honestly. Like, it is like something, and you should be able to write stuff out explicitly. But the problem with this is that I relied really heavily on the fact that, like, this initial equation was only one term long. Or not one, sorry, not one. I relied on that being like a finite length equation. So you could say, okay, the AIs are given explicitly by linear recurrence after a while. And once I have an x which is not the root of any Q polynomial like this, that advantage is going to go away. Yeah, that's why I'm not bothering to work out the ending of this, because it's just there's some calculation, but it's not going to help us in general, I think. Oh god. Like this feels like I feel like this is the kind of thing where it's like, yeah, it should be, it's definitely true and it should be doable, but rigorizing it, the execution is going to require some work. So the fact that x is at least 1.61, like x is at least phi, means that x plus x squared is strictly greater than 1 or something like that. Which, I don't, why is this there? It's like I should be able to generate a bunch of non-trivial relations if X is large enough. I think is roughly what it's trying to say. What those relations are, I have no idea. Because it's just there's infinitely many variables. So infinite dimensional linear algebra really sucks compared to the finite dimensional type. Do these power series generate convergent power series? Coef restriction. I don't think that like if a lot of EIs are equal to actually hang on. Oh, that's a good point. Wait, yeah. Hang on. The geometric series is actually yeah. X is less than 1. Okay. You are totally correct. You can just ignore the EN constraint. Yeah, that's a good point. You can just add a bunch of copies of things if you want. Actually, wait, hang on. Let me think this through. So if you have an EI sequence that has things outside of -1, 0, 1, you need to be able to split it into smaller sub things that are convergent and are restricted to -0, 1, 0, 1. Is that correct? Is that what I'm trying to get at? Everything's absolutely convergent because X is strictly less than 1, so I can rearrange however the heck I feel like it. Yeah, it would be nice to... Yeah. Crap. Yeah, okay. I'm totally because like if you want to split one that has EIs outside of -1, 0, 1, then you need to break it into smaller, well-behaved things, which I feel like ought to be possible, but I'm not 100% sure. So okay, if X is at least 1 over phi, then yeah, if X is at least 1 over phi, then it's just broadly true. I think that if X is at least 1 over phi, 1 over phi, then there exists a set S of positive integers such that 1 equals sum of s and s, x to the s. When it's exactly 1 over phi, it's the entire set of integers. But the point is you can always rewrite 1 as a sum of powers of x, of distinct powers of x. So if the coefficients are bounded and positive, yeah, you can... Wait. Okay, positive is not what you want, right? Because it's, you know, the sum is supposed to equal 0. But if they're... Actually, now that I'm looking at this thing about s is true even when like x is like a half, right? Is this problem statement true for x is a half? I'm actually curious now. Because if it's 1/2, then it's actually literally just binary. So I think it's not actually true for x equals 1/2. Oh god. Okay. Oh no. I'm saying the problem statement. Like, is it true that so for some en half to the n to equal 0, I think you need to have 1 and then all minus 1s after that, right? Is how it comes out. There's no other combination that can work. You take the first, or either that or it's negation. So then the question is like, can you come up with dumb examples of sequences for which every term is equal to the sum of all the ones after it? And the answer should be... Actually, no. I think the answer is no. In other words, an also does have to equal 1/2 to the n. Because you have the system again, but the system says like ai is equal to ai plus 1 plus ai plus 2 ... and ai plus 1 is also equal to ai plus 2 ... So each thing is half of the previous one. So I almost feel like this should be true even for like x at least 1/2 instead of x at least v minus 1, but I'm not 100% sure. Because this statement is true for x at least 1/2, and I feel like this is all you need. I think maybe. I'm not sure. Yeah, I don't. Yeah, that's what I feel like it might actually be true for all x at least 1/2, but I'm very not confident in that guess. I made this for yeah. Well, either way, it's good to know it is true for x equals 1/2, For like random x between half and 0.618, yeah, I don't know, man. But we expect to have x which is have values of x which are not the root of any integer polynomial, just period. Because you like there will be transcendental x, so there's no way around having infinite thingies, just broadly speaking. So it feels like a little surprising to me that like x equals 1/2 would work, but like random algebraic numbers or random transcendentals between half and 0.618 would not work. It has to start with this, right? Like this is the only way the solution can begin, is by saying here's like the like a relation, or not even a relation. This is like the relation or something. If you have transcendent, is that true? Like in what sense are the relations unique for larger values of x? They actually aren't, right? Like depending on how big x is. If x is a transcendental number that's slightly more than 0.618, do I expect there to be more than one interesting relation? I think the answer is yes. But I'm also not using the -1 yet. So far, everything I'm doing is mostly 0, 1. I haven't used the -1. Oh, okay. I'm okay. Never. That's not quite true. I'm using the -1 in the sense that like I'm using the first thing is -1. Everything else is not negative. Oh god. Yeah, this is really rough. It's like I'm doing infinite dimensional linear algebra where every equation is infinitely many variables, and I just don't know how to eliminate any variables. Like here, because some of the equations were finite, we could get a handle. But now every equation is infinitely many things. I don't see a reason to believe they should cancel out super nicely or anything. So I don't know what I'm supposed to do. I agree the sum gets small. I'm not sure how much I believe that, well, is a good thing for me. Okay, here. I will at least say this. Wait, something was written. Sum A at least 2, sum A. Oh, that's for x equals 1/2. Yeah. I would say actually, okay, it's not unique. The reason is this: if x is at least 1/phi, then there exists sets S and T of positive integers such that yeah, and this is I would believe this is where the 1/phi would get used well. There exists S and T such that this is true, and 1 is in S, but 1 is not in T. So there's a representation that uses 1 in capital S, and there's a representation that doesn't use 1. And these two should be quote unquote different, whatever that means, because they don't line up. So can I get some system of some shape out of this? Maybe. Uh. 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 Shoot, I have no idea. Meant to do. Yeah, it was nice when S was 1, 2. I was really happy when S was a finite set. I don't think it's going to be a finite set anymore. Actually, I can be a little more precise than this. I can say S contains S contains 1 but not 2. Oh, sorry, that's not true. Is that true? No. Okay, if X is strictly greater than 1 over phi, then I can do that, which is fine because I guess we can do the phi case by that's gross. That's fine. While 1 in so I can rig it such that I get actually, I can even do this with I can get a set that has 1 and 2, a set that has just 1, and a set that has just 2, and a set that has neither. Okay, now then it's getting somewhere. Is that good enough? Wait, okay. First, let me verify it's true. X cubed plus x to the 4th plus x to the 5th is greater than 1. So a greedy algorithm with x plus x squared. Okay, I can't necessarily get. Oh, sorry, I can never get both, but I can get one or the other or neither. Is neither too small? Sorry, you're right. Yeah, neither is too small. Sorry, my bad. Okay. But I feel like I like this because this is actually letting me use the phi at least a little bit. So I have these representations. These representations are like don't look like they should have anything in common. And then also these representations shift. So yeah, my goal is to relate A1 and A2 in that case. So I know A1, I want to pin down A2. And the only way I'm going to be able to pin down A2 is if I can produce some inequality that's like... I have no idea, actually. Heck if I know. Oh, there's so many variables. What the hell is this? Oh my god, why am I doing infinite dimensional linear algebra? What do I do? What do I do? Okay, actually, I actually take back what I said. This is okay even if x is 1 over phi, because s will be the set 1, 3, 4, 5, 6, 7, 8, 9. And then t will be the set 2, 3, 4, 5, 6, 7, 8. So if I have something like that, can I... how do I diff them? Like, how do I show the AIs are approach 0? Is actually, maybe that's the actual question. Is like, how do I show that the AIs, eventually tend to 0 even in the infinite situation? If I have like some big late AI, or can I show the AIs are non-negative? No, that's not. Oh my god. I can't get anything. Well, okay, some E and AN does actually have to equal 0. So there's like some condition saying the sum of the AIs is convergent. It's like converging to something. Which should tell you something of some sort. I don't know. The shifts of S minus T are linearly independent. Hi, Evan, I'm back. How was the CF problem? I think I eventually decided that I didn't think I was going to really get it. Like, so I got told that you can do swaps in 6N, and then it was kind of like, okay, well, this is roughly what's up. I don't know. I think we decided it was not a clean solve anyways, so I was just like, eh. And then we did watermelon. And I did not get wrong answer. Miraculously. Yeah, and now we're doing this, which I also feel like I thought like this was going to be okay, because this feels like the kind of thing I'm better at. Then I realized I'm doing infinite dimensional linear algebra, where every equation in the system has infinitely many variables. And then I was like, oh god. Yeah, today has been a rough stream. What the? Echo, stop. I see, yeah. I don't think I was gonna get that, so it's fine. Yeah, I don't know. I feel like today is just not my day. I'm like not getting anything. Except watermelon. I got watermelon. Yeah, if you write it up, I'll put it on the IOI unit. Spawn was rated 3000. Amazing. Yeah, I don't. I don't see how you eliminate any variables, and I don't see how you can. The thing is, like, sum a(n) equals. Okay, if there are sets, like if I have a bunch of real numbers a(n), and I know that like some subsets of them are like sum to 0, I should at least know the things in the set. Like a(n) converges to like for s and little s, a sub s by definition converges to 0. Have like a like limit s and like this is by definition. Like the a is actually just so I at least know that like inside here things are pretty so if I zoom in on just that, the problem is like s might be pretty sparse. It might not have very many elements in it. It's also true for t. Oh god, I really Jesus. Like S and what I really want is maybe like what I want is a large, like I want a set with a bunch of things in it, or at least be able to. Can I get an like to at least converge to 0? Like I want at least that much progress. Is that I want just, are there any values of AI that are never read? Maybe that's a better way of phrasing it. The answer is no, because you can but they're at the head, not the tail. A You have a set of linearly independent. Does that work with infinite dimensional stuff? I feel like I don't actually understand how infinite dimensional linear algebra works. Um, like you diagonalize the first k of them. Am I just using S or am I using both S and T? Okay, like okay, I agree that I have like a system of equations that's like a I equals sum s in S of like ai plus s for every this is true. And in particular they all yeah, okay. So I agree it's a diagonal set of equations. Yeah, like they're actually linearly independent literally because it's like they start out diagonally. I agree it will have to be bounding. I just don't know how to actually execute anything. It's like so the problem with this is that I actually don't use T. Like this only uses one set S. Like I only need one. I don't need T if I just want a diagonal equations. But because like they're giving us that X is at least 1 over phi, I have a feeling that one set will not be enough to execute this. Yeah, I'm really not feeling it today, man. Okay, so let's assume they're wait. You're assuming there's a single K or just wait, actually how does this work? Oh man. I'm actually curious where this poem's from now. Is this like... Yeah, where is this from? This doesn't feel like a high school Olympiad problem because it's way too... I feel like it's way too much analysis to be... It feels like the kind of thing that would show up on Miklos Schweitzer. Yeah, like, I don't know. This doesn't have the high school feeling to it. It feels... I don't know. Not that that's a bad thing. I think I like problems that are like this. I'm like trying to guess what the source is, and I'm just like, I think you start by ruling out every high school contest. This is actually from a high school contest? Really? Which one? Oh, it's actually from Miklos. Huh, okay, so I'm not wrong. I was like, really? This feels like so much analysis for high school. It's actually from Miklos. Okay, I have good instincts. That also explains why I'm getting nowhere on it. Because that contest is so tough. Oh, gosh. All right. Yeah, all right. I honestly think I'm too tired to keep thinking about this one. I don't think I want to read the solution yet because I might want to play with it some more later, but I don't think I want to get it tonight because it's been a long day for me. Do I just shoot down the IMO one and call it a night? I could just do that. Yeah. I don't expect the solution to be long. I just don't think it's gonna be easy. I feel like it's not gonna be long because there's not enough, like, I don't know. What's the word? Like, I feel like the statement is clean and it's like you can see intuitively why it like has to be true. So it would surprise me if you couldn't compile that intuition into like a fairly like reasonable proof. Reasonable is maybe the word I want. Is like if it doesn't feel like it's something that's going to involve like a really gory calculation, because you're like, it's intuitively true, and it also feels like it's the kind of thing where like, yeah, your intuition will tell you what the correct proof is if you're good enough. Maybe, I don't know. Okay. Yeah, I think I'm just gonna shoot down the IMO one to make myself feel a little better, because otherwise this will be the first stream in a while with no solves, and then I'm gonna go sleep or something. Okay. Okay. So, as a consolation prize, we're going after an IMO one. So, why is the board not refreshing anymore? Ah, come back. Is it the iPad end, or it's on? I think it's on this end. So, okay, we have wait, what? Wait, how does area make sense if you're coloring the points? Oh, are the vertices of unit squares? Okay, so okay, fine. Okay, so in this problem, wait, is this one just gonna be like incredibly bad? So you have M, and it's asking about like the. Okay, yeah, this problem feels like it's not gonna be that cool. All right. So it's gonna be talking about a right triangle, but honestly, let's just draw the whole rectangle. So you checkerboard the plane, and then you take a right triangle that's axis aligned, and then you didn't have it. Oh god, 6 years. Yeah, that's I never figured out where Miklos Schweitzer, like the official solutions, are posted. Okay, and then you're looking at the absolute value of the black part minus the white part is what's going on. So A is definitely 0, right? Like, just if they're both even, it passes through the center of the rectangle, and that's, hang on, all right, let me actually just draw this stupid picture. So I guess the first thing I should say is that you actually kind of know what, well, actually this might be a little more annoying than I want it to be. There's like a region that's like half cut. Okay, so okay, let me draw an odd case just to make sure I see. Wait. When m equals n equals 1, f of 1, 1 is actually not 0. It's a half. If they're both even, I think it should be 0. Because... yeah, so okay, let me actually write stuff down. Okay, I take back what I said. Part C actually looks like it will not be that stupid. But I think some of these other parts look like they're not that interesting. So when it's even... Where's my blue pen? Blue pen. If it's even, then there's a center that it's passed through. And we're basically really just interested in the, is that true actually? Hang on. Wait, how do you do this? I thought this would be a symmetry argument, but it's not. Because if I take a, like, mn equals 2, like, this is black and then this area is white. So it is 0, but it's not 0 for the reason I thought it was. And then when it's both odd, is actually like... Okay, so what's going on? Okay, I might actually need some setup. I thought I could just run it over with some stupid symmetry argument. But I am being a little too arrogant right now. So I'm gonna start by factoring it. We're gonna factor m and n as like dA dB, where d is the GCD of the two numbers. And what that means is you're going to have a bunch of A by B rectangles. And in each of the A by B rectangles, you're going to have the line is going to run through this chain-like thing with some, I mean, it looks something like that. There's going to be a plus b minus 1 of these pass through. And then you're going to have a bunch of copies of this. So you're going to have like d copies of that. And then you're going to have some rectangles that are just checkerboard colored the usual way. So something about this really bothers me, actually. Like it said calculate f of mn, and I thought it was going to the answer would just be constant or something. But like f of 1, 1 is half, and then f of... It's going to be like... If you have f of 3, 3, what happens to that? Is it still 1 half? No, it's still 1 half, right? Okay, now I'm just confused. Okay, okay. Actually, I see how to do the even thing. Okay, I think there is a symmetry argument for the even case, which is that if you have a lattice midpoint, then you do this. The colors of this area of this triangle here, and this triangle here, will be opposites. So these two will cancel, and then similarly for this one and this one. So I can at least do one part, which is that if they're both even, use the pairing that I just drew here. To get the 0. Yeah. Yeah, I agree it should be 1/2 for eminent odd. I'm trying to see if I can't tell why that's true. Do I just do the if it's both odd, can I just do so I know it passes through, the line will pass through the center of some cell this time. So can I pair up everything else? Is that a thing I can do? Actually, I feel like I should just be able to do the same thing, maybe, right? Okay, wait, let me actually check this. I'm gonna draw 3 by 3 just to make sure I'm not being stupid. I'm probably being stupid, honestly. But wait, why is it always 1/2? Oh, Jesus. Wait, this is shit. That's not how odd numbers work. This is 3 by 5, right? Damn it. Okay, so all right. All the black squares should. God damn it, no. Also, this line is not great. Okay, today is really not my day. I don't know why I was trying to do hard problems. I can't even do stuff like this. Okay, so I want like this thing and this thing to add up to 1. Yeah, I think that's basically what should happen. Okay, so what's the pairing? Is it... If I do the GCD thing, then the yellow path is symmetric and consists of a plus b minus 1 things. The other chunk is oh, this is going to be really annoying to write up if this is what I'm supposed to do. This is odd if a and b are both odd. And what you do is you pair the yellow things from using a symmetry to show that only the center thing contributes and everything else cancels. Or not cancels, pairs up. Wait. What the hell? Wait, okay, which cells of this are... God damn it. Okay, which cells of this are black? It's like this, and then this. This. Like, the point is this thing adds with this, and this thing adds with that. Of the, do I really need to micromanage this? I feel like I really shouldn't. It should just be a half, and it should be because of like the extra Y region. But I'm really... I feel like I should be able to do like some sort of like reflection argument or something, so I don't need to do this by hand. Oh, okay. I think, do I draw this line? I think it might be just this line. Okay, I think I got it. You take... Okay, yeah, there we go. I was like, there should be something like this. You take this chunk and then you like move it, or not, I shouldn't draw the whole rectangle. You take this thing and you like move it here. So you take it and you spin it, so it lands in the right place. And now you have just, yeah, there you go. Okay, that's fine. Actually, this probably works for the even case too, now that I think about it. Yeah, okay. Actually, this will work for the even case as well. Because like, because the midpoint is either the center of a cell or is a lattice point itself, then you can, yeah. So you rotate it and now you have a rectangle with half the size. And we are okay. Alright, that took way longer than it should have. Okay. So then that begs the question of like, why does this not work for if M and N are... If I do this, I draw this red line again. If I try to do the same thing here, is it just like the parodies don't line up? So like this is black, and then this is white. Yeah, so the parodies don't line up. Okay, that's fine. Yeah, so they have that, what's it called? Yeah, cool. Yeah, as the difference for the entire board. Oh, you want to just take the whole rectangle? Oh, okay, for part A. Okay, fine. Okay, half max mn. I don't really want to do this now. Okay, what is f of like 1 comma n? I'm actually curious. Should be computable, right? Because everything is... So, so the black area, let's say uneven, of course. It's the sum of a bunch of trapezoids of various height. So this black minus this white is what? I really need to sleep. I can't even compute this. Just 1 over... It's like 1 over n, right? Oh wait, so okay. Okay. Where was I though? Okay, so part B, if I do that, the GCD thing I was talking about, actually that's no good. It does suffice to check it for, because in the when you do the GCD trick, if m and n are opposite parities, which means that a and b will be as well, then all the lower rectangles, like these thingies, those will all be balanced. So I only have to pay attention here, and is there... I want to show it's at most half m and... Come on, this has to be... There's n plus n minus 1 over 2. Or a plus b minus 1 over 2. Is it true that the remaining region is balanced? Wait, it might not be. Can I just do, if I do the folding argument again, even though it doesn't work, will it give me an inequality of some sort? Like if I do the spin on if I do the spinny thing and put everything here, what I get is this deranged grid where the colors are kind of strange. Right, but within, there's like a discrepancy of at most 1 in each row slash column, I think. So it shouldn't matter, right? Am I high? I think I'm being stupid. I really should just sleep now, but I just feel so bad if like I jump to this as a consolation prize and I still don't finish it. Today's really not my day. I don't really like the spinny thing that much for part B'ers. Okay, but can I just say like the discrepancy, like the amount of black minus white in a column or row, well, like just in any column, is at most it's at most 1. But I know that much. I don't think that's enough. I want to like oh my god, this is so embarrassing. Like, I could just compute everything, but it's so annoying that I really don't want to. There's gotta be a clean way, right? Thank you for the follow. Isn't at most just one done? Is it true that there are discrepancies? I'm really tired. I think you're probably right. In a given column, I claim the discrepancy is at most one because I think I need like if I have a red thing that cuts somewhere, then and I assume the slope is less than 1, let's say, with also generality. Yeah, if the slope is less than 1, then in a column you should be okay, I think. Because there's at most 2 cells that are screwed up. And then if you look at the cases on which cell is screwed up, you're fine. So like some white and green. Is there really no better way for me to like check that? Okay, I'll just write these both out. So one case looks like this. So you have some white green and then some partial white. Or either a partial white or a partial... I think this is just be fine. Okay, and then C follows by taking F of like 2 and N for odd N, right? Whitlock. Is it? Wait, is it actually false? What if N is... If you had height 2 with the cut almost horizontal in the middle. Oh, sorry. Our definitions of discrepancy are off by a factor of 2. I was actually doing like the part inside the triangle. Right. Okay, the problem actually asks for over 2. Oh my god, this is so annoying. Oh my god. Come on. Okay, can I at least quickly sanity check that I'm not completely drunk and wait, I think I'm stupid. Hang on. I'm being stupid again, aren't I? Yeah, I'm being dumb. Yeah, that's not a chessboard. uh. Okay. It's been 40 minutes. I can't believe this. Can I just motion to adjourn at this point? Because this is... Even if I solve this, this video is going to be really embarrassing. I'm just going to be like, just... Yeah, okay. I... Today's probably not it. I got watermelon correct. That's my accomplishment for today. Yeah, maybe next week if I'm like not feeling as crummy, I will try to actually do the IMO one. But this is getting ridiculous. I can't. Alright, thanks everyone for coming out. Hopefully next week will be better. This is really not it today. Oh my gosh. I'm gonna go get a lot of sleep.